So next we're going to be getting into radical functions, and we're going to start with graphing radical functions. Well, radical is a root, so the parent function for this is going to be just the square root of x. When x is inside of the radical, that makes it a radical function. So let's start off by how we always start a new function and graphing it by setting up a table of values. We're going to have -2, -1, 0, 1, 2, 3. So when I plug in -2, I'm going to have the square root of -2. Well, because it's negative, means that it's undefined. I can't do that one. Same with -1. It's not real, so it can't go on the plot of my real plane. So the first one I'm going to get is 0. So that's going to be when I plug in 0, I get y is equal to 0. When I plug in 1, the square root of 1 is 1. When I plug in 2, well, that's not going to work. It's going to be a decimal, 1 point something. This is going to be 1 point something. And the first next whole number I get is when I plug in 4, and that's going to be at 2. So when I go ahead and plot these, I have the point 0, 0, the point 1, 1, and the point 4, 2. And if you can tell, my next one that's at a whole number would be where x is 9 and the y becomes 3. So it looks something similar to this. Okay, just to understand what the graph is going to look like, we're going to go from here. My domain would be x is greater than or equal to 0, or in interval notation from 0 to positive infinity, and the 0 is equal to, so I have that brackets there. My range is the graph is going up from 0, so y is greater than or equal to 0, and the same from 0 to positive infinity. So remember how I said that A, H, and K is going to be coming back for the rest of the year? It's back! So it's all the same stuff as it was before. I'm not going to list out all of the things that they do, but again, the A, if it's a negative, reflects it across the x-axis. If it's greater than 1, it's going to stretch it. If it's less than 1, it's going to compress the graph. The H shifts it in a negative direction, in the same, or I'm sorry, the H shifts it in the x direction horizontally. And remember, it's a negative, so you have to go in the opposite direction of what the sign is in the function. And the K shifts it vertically up and down. All the same stuff. So for this one, to describe the transformation, this is going to be shifted. It's a -2, so it means right 2. It's a +5 here, so that means up 5. So that point is what's shifting. That point that was on the origin is what's shifting. And it's going to go up 1, 2, 3, 4, 5, right 2. So now your graph is starting at the point 2, 5 instead of the origin 2, 2, like, or I'm sorry, 0, 0, like the parent function. You had that next point at 1, 1 here from the parent function. So your next point here is going to be 1 up and 1 over at 3, 6. What I like to do, the table that I like to make is that starting point where the parent function is the origin, what's shifted, it starts at 2, 5. And then I want to make what would make this radical a 1 and plug in an x value that would make this radical a 4. So if I plug in a number for x that would make it 1, that's going to be 3. And if I plug it in, 3 minus 2 is 1, plus 5, square root of 1 is 1, plus 5 is 6. So I have that 0.36. And then what's going to make that radical a 4? Which is going to be 6. 6 minus 2 is 4, so that's square root of 4 plus 5. So that's going to be 2 plus 5 is 7. So when x is 6, y is 7. So I have that 0.67, which is going to be here. We didn't talk about the in behavior yet, so let me go to the domain and range and we'll come back to the in behavior. So my domain, looking at the graph, all the x values are going to the right from when x is 2. So that means x is greater than or equal to 2. Or in interval notation, 2 to positive infinity. And my range is going to be all the y values are greater than 5. So y is greater than or equal to 5, or from 5 to positive infinity. So let me first look at the easy part, which is as x is approaching positive infinity. And so as x is approaching positive infinity, which means as the graph is going to the right, the y value is going to be going up. So the graph, the f of x, is approaching positive infinity. It's this point that is going to be a little bit tricky. But all it is this point. As x approaches 2, f of x is approaching 5. So it's basically just your x value and your y value right at that ending point of the graph. I have my description, domain and range, the in behavior, and the sketch of the graph. So we're going to keep the same directions here. Do the description first. Well, this one is a negative, so it's reflected across the x-axis. It is greater than 1, so it's stretched. And remember, that's not referring to the negative part. So it's stretched by 2. It's shifted left 3 and down 1. Now the shifting, I'm talking about my h and k. So remember the opposite of the h. This h is still inside with the x. It's still shifting with the x in the x direction. So that point here is going to be shifted left 3, down 1. And being reflected over the x-axis means that it's going to be going down instead of up. Okay? And that's going to change my range. We'll talk about that when we get there. But let's first go ahead and make that table. I have my first point at -3, -1. And from there, what x value would make this a 1, which would be -2. And when I plug in -2, I'm going to have -2 times the square root of 1. Well, that's going to be -2 minus 1 is going to be -3. And then when I plug in, let's make this a 4. X being +1 would make that a 4. So when I plug it in, I have -2 times the square root of 4 minus 1. -2 times 2 minus 1. -4 minus 1 is -5. So those are my 2 points. So I have the starting point, then -2, -3, and +1, -5. So the graph's going to look like this. And it's going down, remember, because this is a negative. So my domain is going to be all the x values greater than or equal to -3. So that's going to be from -3 to infinity. And my range, this is where it's going to change because all the y values are going down from this point. So it's going to be y is less than or equal to -1. And writing this in interval notation, you always go from the lesser value to the greater value. So it's going from -1 to -infinity, but negative infinity is the lesser value. So I'm going to say from negative infinity all the way up to -1 and including -1, so my bracket is on that one. My end behavior is as x is approaching -3, f of x is approaching -1, and as x approaches positive infinity, f of x is approaching negative infinity in this case because the graph is going down. As it's going to the right, the graph is going down, so f of x is approaching negative infinity. And there you go. You got this part, my domain and range, and my end behavior. And the graph, of course. So we're going to do a quick inequality square root function, and then that's it, and then some u-tries. So first, graphing it's the same. We just got to pay attention to those two parts, whether the graph itself is dotted or solid, and which part to shade. So for this one, it's going to be shifted right 4 and up. I'm sorry, right 4 and down 6. So that's my starting point, which is going to be right here. And it is a positive A, so it is going up. I got room to maneuver. What's going to make this square root a 1 is if x is 5. So if I plug that in, that's going to make that 1. So it's going to be 1 minus 6 is -5. And if you notice, because it's not stretched or compressed, that first point is up 1 over 1. And then my next one is going to be what's going to make this radical a 4, which is going to be if x is 8. And if I do 8 minus 4 is 4, square root of that is 2, minus 6 is -4. So I have the point 8, -4. Before you go ahead and draw the graph, pay attention to whether the graph is going to be solid or dotted. And because there is not the equal sign here, my graph is going to be dotted here. So the graph looks like this. It is less than, so it's going to be shaded down. Now, it's a little bit tricky. Basically, the graph, the shading stops where the x value is on that ending point of the square root. So it's going to go all the way to the x value and stop there. It goes further down than that point, but I can't have an x value that is less than that point. So it's going to stop at the x value. Okay, so here are a couple u-try problems. Go ahead and pause it. Try to graph these. For the first one, describe the transformation, give the domain and range, and the end behavior of the graph. And then the second one, just graph the inequality. Okay, so here are the u-try answers. The first one is up top. I didn't have enough room to do the second one on that second graph. So the first one is here. You should have this table, and the graph looks like this. All the description, domain and range, and end behavior here. And the second one should be dotted, going down because it's a negative, and you have these points on there, and it's shaded down. And it should be stopping at the x value of that ending point as well. And there you go. All right, so here you go. Well, it's black, white, and green, and black and white. Two zebras fighting over a pickle.